Hypercore is a set of building blocks to build distributed peer-to-peer applications. It provides a variety of data structures as well as a discovery mechanism to share data between peers. So Hypercore is a suite of tools that are the Lego blocks to build peer-to-peer apps.
One of the main reasons that people don't build distributed systems like from the ground up is because it's hard, right? It's like harder than just throwing things up on a centralized server or having one machine.
Yeah.
And so the fact that they're able to build some of these building blocks to make it easier to build some of these other applications on top definitely is a boon.
Hey, this is Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
And this is Will. I'm a YC alum and independent researcher who's worked across e-commerce, cryptocurrency, and financial industries.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it, an optimistic look at the road ahead. We're just two guys discussing edgy, fringe, or overlooked technologies over a couple drinks. Our show has 3 segments. First, we give a high-level outline of what the technology is. Second, we talk about what we can do with it today. And lastly, we let our imagination and optimism take over and see how the world would change if the technology was readily adopted everywhere. We can't be experts in everything we cover, so if you've got insights on this topic, let us know in the comments. And be sure to check out our audio versions on Apple Podcasts or Spotify, so you can go about your day as you listen. But first, what are we drinking today, Will?
This time I just also picked up some more kombucha. Synergy? I don't know if I had this on the show already or not, but it's Lavender Love. So yeah, hopefully, I guess I'll be feeling it. I'll be feeling it more throughout the entire episode.
Great, cool. Well, hopefully you fall in love with the topic this week. I've got something significantly more mundane, but I've got Canada Dry, 0 sugar ginger ale. Just needed to settle the stomach a bit.
Wait, is the 0 sugar just that it's a fake sugar, or it's actually not sweet at all?
No, it's fake sugar. It's
oh, I see. One of those things. Yeah. All right. So, given that, what are we talking about this week over our drink?
Yeah. So this week we are talking about Hypercore. Hypercore is a set of building blocks to build distributed peer-to-peer applications. It provides a variety of data structures as well as a discovery mechanism to share data between peers. So Hypercore is basically a suite of tools that are, you can think of them as the Lego blocks to build peer-to-peer apps. The main data structure at the core is this technology called the Hypercore. It's an append-only log database, which is similar to Kafka. And so that powers all of the other suite of products. On top of this data structure, they have a key value store as well as a distributed file system called HyperDrive, which can be used to share data across the internet. And so, yeah, you can think of this kind of like the AWS of distributed apps in that it provides the tools on top of which you can build full-featured applications.
Right, except the naming scheme is consistently hyper.
Yeah, everything is prefixed with hyper.
Whereas AWS has all sorts of names, and you don't actually know what it is until you dig into it a little bit more. But yeah, like I think this was pretty interesting. I think for whatever reason, I didn't really pick up on Hypercore until we had to do this episode, and for some reason, because I've heard of some of the other like distributed P2P or like tool sets that allow you to build these distributed applications before. But yeah, like I think they really got to find that one thing that really grabs people. And I guess like you said, the key to success of any platform is when an app builds success upon it. There's like $1 billion company, and then other people are like, oh, I guess we got to use it.
Yeah, we should do it. Yeah. No, Hypercore is pretty obscure even among the technologies that we tend to cover on this podcast. Like, it was pretty hard to find resources about it, but I think it's a bit of a branding issue with this project because they've been around for a while. I think going on, 7 years, something like that. Yeah, exactly. And they're contemporaneous with more famous projects that we've covered in the past, like IPFS. And I think the thing with Hypercore is that they started life as the DAT protocol. So that was something that was kind of popular.
Yeah. It's something that I remember really resonated with the HN crowd on the Orange site. So I wouldn't be surprised. I had always put the DAT protocol on my to read list, and then eventually the page expired, and then I didn't know where it went. There really should have been like a redirect, because I didn't know that it turned into Hypercore.
Yeah. Yeah. So there was a DAT protocol, which was, I think, focused on this sharing of scientific data sets. And then there was a somewhat famous project called the Beaker browser, which was a browser for the DAT protocol. And then since then, they've rebranded using a lot of the similar technologies and learnings from those early projects. But now the focus is much more on, like you said, these SDKs, these primitives. And they've done some interesting work about building quite complicated ways of structuring data using all built on top of this one fundamental idea. The fundamental idea is that of the hypercore. It's an append-only log. You can almost think about it similar to a blockchain, or without the distributed consensus part of it. Or
So for our reader or listeners out there, like what is blockchain without that effectively? Like, so it's the in the same way that Git is an append-only data structure where you basically keep adding data to it, and the data is immutable and is always there, and then the things that you do are all on top of that, assuming that nothing will go away.
Yes, exactly. So just like Git, it has into it the idea of basically a chain, a sequence of changes to the data structure, as well as ways of efficiently traversing the history and streaming updates from that data structure to other clients that are listening, the same way that you can do a Git pull or something and pull only the data that you need. And so that's the core. And then I think on top of that, they've built, like I mentioned, some more tangible, like concrete things. The most famous of which, or the most obvious of which, is HyperDrive. HyperDrive functions similar to IPFS, which we've covered before, in which there is a folder which you can pack with files and then expose that over the network, and then that gets shared across a peer-to-peer swarm, as they call it. So they have another network protocol called Hyperswarm, which is similar to the BitTorrent protocol. It's a way in which peers can discover each other and discover the resources that they're exposing, and then connect and share that data with each other. So one obvious use case for a technology like HyperDrive is to share some files. You could have a HyperDrive folder full of some files, and then that gets distributed peer-to-peer.
Right, and it's you can share files through centralized services now, but so then presumably the reason why you would want to do this in a distributed manner is either like the data set is too big and you don't want to like pay for the server costs to like the bandwidth costs to service everybody that would want it, because then you have all your peers to help you service that.
Yep.
And so I think that's probably a major reason. Are there others? We can get to it later, but I guess let's put a pin in it.
Yeah, we'll return to that. So there are a lot of sub-projects within Hypercore that are built on top of this data structure. We're not going to go through all of them in exhaustive detail, but the one that I found very interesting and ambitious is HyperBee. It's a key-value database that's built on top of Hypercore. It has you can think of it almost as a storage engine for a serverless database. So there's no database server, but it structures and stores the data and indexes the data such that you can build your own query engine that runs on your client, and then it seeks out the data that it needs from the swarm and pulls down the blocks that it needs in order to fulfill its query.
That is deliciously interesting, because I mean, I think to IPFS, like their primary data model is around files and file systems. And I always thought one of the things that they were kind of missing was a way to treat the data as a database. And while this is like a key value store and still like relatively underpowered when it comes to all the other different kinds of databases that are possible, I think key value stores are the very basis of some of the other ones. And so it's not inconceivable to start building some of the other ones on top of a key value store. And so, for example, in our last episode on Datomic, I mean, one of the things about Datomic is you can swap out the actual storage with any number of databases, because it just treats them as effectively key value stores, and then all the other features that it has, it builds on top as part of the client, because they kind of deconstructed the database, right? To take terms from the culinary world, they deconstructed the database and then spread them out differently so that they're not just all sitting on one server. And so you could presumably do that on HyperBee as well. And so it's really interesting that then you can see a straight shot from there to like building applications that have just as much power as the current centralized web apps today, even though the architecture is a little bit different.
Yeah, exactly. And I think people are figuring out how to structure their data to fit this model. And of course, the reason why they're using these concepts like an append-only database and key value stores and things is that these are, again, data structures that are optimized to be shared peer-to-peer rather than going through a centralized server. And so it's going to look different, but I think people are figuring out the design patterns.
Yeah, I mean, it's definitely inspired by functional stuff, and we definitely covered that way back in season 1, episode 4, or something like that. And so we'll put a link up here,
Yeah.
where we discuss that if you're interested. But yeah, slowly but surely, functional programming ideas are filtering out to a lot of core technologies that are up and coming.
Yeah, totally. And the last thing I would say that's important to know about Hypercore is that all of these data structures are single writer by default, meaning that there's only one secret key that can update the data structure, and the changes then get propagated to the peers on the network. But these are not inherently multi-user collaborative data structures. There are some projects and offshoots that are trying to build things like real-time editing and conflict resolution between multiple writers on top of Hypercore. But at its core, the fundamental use case that at least the core team is optimizing for is more of a broadcast of updates. So you have some data that you want to propagate to peers rather than thinking about this as a shared data structure that everybody writes to.
Yeah, this is very much in line with the local first software that we also covered way back when, and
Yeah.
the episode that we'll link to. And I guess I don't know, maybe we're just circling around all the related technologies, and maybe we need to branch out into some hardware sometime, so we wouldn't always be
Yeah.
so self-referential. But yeah, like I think that's part of the reason why this is exciting, because at least for me, because it's one of those holes that I've been circling around. I wasn't aware of it until we had to do this episode.
I think the reason why Hypercore is interesting and the reason why I picked it is that there's something there, and it's hard to tease apart exactly what it is, but it seems to touch upon like a lot of things that like are on our radar.
I see. I thought you were gonna say the twinklings of a billion-dollar company or something like that. But
Well,
yeah,
maybe.
maybe. Like I wouldn't put it past that. But yeah, like I think like you and I don't know. We'll see. Maybe we really should be investors to put the money where our mouth is to see whether we really have good instincts on whether there's something there or not. But yeah, I mean, hey, if anybody wants to give us money out there to start our own fund, by all means, we'll start the Technium fund. But yeah, I think at least with our technical instincts, like it really feels like there's probably something here that you can build things that are uniquely interesting and have unique user propositions out there.
Yeah. So yeah, maybe we can go into a few of those things and then see if we can imagine what it would look like if all developers were familiar with Hypercore as a tool in their toolkit. So
Yeah, let's go.
yeah. So the most obvious one, if you look at HyperDrive, which we mentioned is the shared distributed file system, is that you can imagine that it is a alternative to centralized services like Google Drive or iCloud or things like that.
And so, for example, why might you want that? Like, why would you want something like that as opposed to having, I don't know, people that haven't had bad experiences with Apple iCloud or Dropbox or Google Drive or something like that?
Well, yeah, I mean, I think ultimately it comes down to data autonomy. You know, it is a single point of failure if you have some files, especially sensitive files or critically important files, that to rely on an external third-party service, which could be shut down or arbitrarily change their quota limits. And so you're really at the mercy of these cloud providers to do what is a critically important workflow of any type of, work on computers, which is to store data. And so I can imagine that instead you might say, well, what if I could just host my own data and then propagate that myself? And what's interesting, and we talked about this on the local first software episode, is that when we think about people and enterprises moving their data to the cloud, our model with the current set of tools that we have is inherently this centralized model. When we think about companies moving XYZ to the cloud, we think, oh, they're signing on to AWS or Google Cloud or something like that. But I think, like you mentioned a few times before, a lot of these internal tools and data that's typically exposed over the intranet is a very good candidate for something like HyperDrive and Hypercore, because you can just store that data on your own machines and then expose that within your company's network and have that be replicated and shared and updates propagated without relying on a third-party centralized server.
Yeah, and I think it's just the alignment of incentives because, like, usually within transactions over time, the part of the reason why you enter into the transaction with a company is that your incentives are both aligned, right? And so they're willing to grow the network at the same time host your data. But like as companies grow in their users, sometimes their incentives can switch and then become misaligned with you, and so therefore like terms change on you, and so that's where you're at the mercy of whatever their particular goals are, and so when they change, you have to make sure you get your data out because it's important to you, it's not important to them, right?
Yeah.
so so yeah, I mean, and also I guess in a broader historic sense, I think like digital archaeology is probably going to be pretty important in 10, 20, 30 years, if not earlier. And so,
Mhm.
there's a lot of GeoCity sites that are no longer around, including my own. And I think I would have a blast from the past just looking at those too. So, yeah, I mean, like
Yeah.
I think it's something is lost, I guess, if there is not enough of the internet that is saved. And like when it comes to the internet, there's a push for recency, like with Twitter, like recent news, and Snapchat with disappearing, that sort of stuff. I think
Mhm.
something is actually lost. And so, especially cultural contexts that get lost. And so, if we actually
Yeah.
own our data, there might be a chance that we actually save it. So, I guess
Yeah.
that's would be my perspective on the practical versus, I guess, the for the good of the common people sort of answer.
Yeah, no, and I think that's fair to bring it up because, like I mentioned before, Hypercore used to be called the DAT protocol, and the DAT protocol was actually funded by this organization, which was very much interested in archival of data and the sharing of open sharing of data for
Oh
science and the
yeah,
scientific
yeah.
community.
It was like some sort of grant that they got, right?
Yeah, exactly,
Yeah.
exactly. So yeah,
All
yeah.
I
So
remember is
so
their website's blue, but I can't remember the name. We'll link to it in the show notes.
yeah, yeah. So yeah, I think collaboration tools are a very obvious candidate for this. Actually, one of our favorite research labs that we discuss a lot, Ink and Switch, built
Yes.
a tool on top of Hypercore called Pushpin, which is a type of shared workspace where you can put all types of content and then synchronize it across your devices. And so they used Hypercore as well as I think contributed some novel ideas in terms of building CRDTs on top of Hypercore so that there can be conflict resolution. And so you can have multiple devices editing that shared workspace.
Yeah, yeah, yeah. We'll link to it in the show notes. Did we discuss CRTTs in one of our? I'm sure we discussed it at one point way
We,
back
we
when.
discussed it
And
in the
like I
local
said, like
first.
yeah, yeah, like we're just is it circling the drain, or are we just like tying everything together like a madman? Like Anna was it? It's always sunny in Philadelphia. So.
Right, right. No, no, yeah. I mean, it's funny the extent to which a lot of these concepts begin to relate to each other once you start to see enough of them. I think the next obvious use case when people hear about Hypercore is to make the comparison to IPFS, which is, like we mentioned again, another distributed data storage and serving system. And so, of course, Hypercore is also capable of doing a lot of similar things to IPFS. So you could use it for distributed web hosting. So if you had some type of content, maybe a website, personal site like you said, that you wanted to expose and have persisted, you could do it. The interesting thing about Hypercore versus IPFS is that IPFS is a content addressed system by default. So the
Yeah.
address to a piece of content that you're retrieving is the hash of that content, and it's immutable. Whereas Hypercore is actually much more mutable by default. And so if you have
What up?
that, yeah. So if you have the address it's basically a pointer to the latest revision of that append only log, but you have history as well. So all of these hypercore data structures have history to do undo, redo, rewind, replay, and an efficient way to request to go back to a certain revision in the chain. And so it's maybe not all that concerning.
Wait, question. So
Yep.
when it comes to mutability, I mean, the hypercore is built on top of a append only log. So presumably the quote unquote immutability is where they're appending a change at the end of the log, but then they're able to, I guess, either aggregate or like do the diff to say like what has changed, so that technically you can mutate content pointed to by the identifier in the system. So that you get changes for the same link, right? But that entire history is kept. Whereas in IPFS, because it's content addressed, if any content changes, then the entire address changes. But I think they're working on like what is it? A name,
IPFS.
yeah, like a naming system for it.
Yeah.
IDNS, yeah, something like
Yes.
IONS, something like that. We'll link to it in the show notes.
Yeah, yeah, exactly. So you're right in that actually this difference between these two is not fundamental because it's mutable in that the model that it exposes to the user or maybe the programmer who's interacting with this data structure is one of a mutable data structure, but at its core, it is an append-only log, and so all the edits are actually stored as edits such, and you can rewind and replay them and see the history and go back to the state of the data structure at a particular point in the history. And
Yeah,
so,
then I take back my oh no. Like I think that's the way it makes sense because like when I
yeah,
thought about implementing things on IPFS, even just like a static site, I'm like, oh, I'm gonna have to build in this versioning thing where
yeah,
I keep updating and just doing it myself. And that I was just like, I want to do other things right now, so never got around to it. But yeah, it's nice that it's built into Hypercore.
yeah, yeah. And I think the last one, and this one is the least developed and the most speculative, but I guess that's what we like here. So, like we mentioned, HyperBee. HyperBee is again that distributed key value storage engine, which then can be queried by clients efficiently. And actually, there's a company that's using it. It's a major company, Bitfinex. So that's a
Oh, crypto, your favorite.
yes. We're bringing everybody. This is a party
Yeah,
here.
yeah, you're bringing everybody.
Yeah. So Bitfinex is using HyperBee in order to stream data updates, to stream the price signals and exchange rates and things that are going on in their exchange. They're putting those facts into a HyperBee database, and then it means that anybody can connect to that HyperBee database, to connect to that swarm, and then get those updates, and then also be able to query them. So you can use this to backtest trading strategies, right? So you can go back in time and see how a price history of a particular coin, let's say, has changed over time because you can query this database.
Do you know why they decided to use Hyper-V for this, or even just like a decentralized store? Is it the same as what I mentioned earlier, that the amount of data is just so big that it would help to distribute the load among everybody that wants to use it?
Maybe. I imagine there's something like that. I think that the interesting thing about Hyper-V in this use case is that it's a database, right? So they could have maybe introduced an API that you can just call and ask for, what was the price at this time or whatever, what's the price at history. But that means that they're on the hook for looking that up, retrieving it, serving it, et cetera, et cetera. Whereas here, all they have to do is throw this data into this data structure, it propagates through the web, and
Oh
then the
yeah,
clients can then query themselves arbitrarily complex queries, and Bitfinex is not on the hook for any of that.
yeah. I guess in some way, like there's no rights; it's all reads, and so it's not like they're gonna corrupt the database or anything like that. And so
Yeah.
I guess it's the equivalent technical decision to use SQLite to put some read-only data and throw it up on a server using dataset or something like that. And so,
Yeah.
but here you're like distributing the load so that you don't have to pay the entire bandwidth costs. That's pretty neat.
Yeah.
It's like community data, actually.
Mm-hmm.
That's pretty neat.
Yeah, exactly. And so I thought that this was a very interesting and bold decision by Bitfinex to take a chance on this kind of obscure technology. But it gave a vision to me of there being a web of data rather than just a web of web pages. So you can imagine.
Somebody call Tim Berners-Lee because he's been working on something similar for a long time, and his latest concoction honestly was a little unintelligible to me, but I'm giving him the benefit of the doubt as the father of the internet. Yeah,
Yeah, I do remember he released a project a couple of years back that was in this
solid.
space.
Yeah,
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 solid. But yeah, so you can imagine that if Bitfinex is doing this for the data that they know about, which is trading signals, and then other companies expose other public goods, data as public goods. The similar way that a company might open source some software and put it up on GitHub, they might also be able to open source some data and then release that to the community, on top of which people can build insights and applications and charts and things like that. So you can imagine that this becomes a web of data, or maybe a marketplace of data, a GitHub for data, something in which data is
yeah.
like exposed and it becomes a shared artifact.
I mean, I know that GitHub for data is a pitch that comes up over and over again throughout the years with like YC companies, and I
Yeah.
really haven't seen one take off. But definitely, I think I don't know, it's kind of like a selling textbooks. Maybe there's something there. And to my knowledge, I forgot the name. Like there is a college textbook trading that is actually successful now. So I guess there's some combination
Yeah.
of something that works. But yeah, we do talk about this like in our previous AI episodes where we talk about having the embedding space as shared data. And that seems like a really good candidate to put on HyperBee, even over IPFS, because it's centered around data and has a database that you can actually query over just having files in a file system. Maybe for embedding systems, it may not matter because like people aren't going to write queries for vectors. Maybe I don't know. Maybe
No,
they
actually,
would, right? Because you can compile like a select statement or some sort of like SQL like query language into embedding space. So maybe that's available.
yeah, actually, that's really interesting that you mentioned this because there are a variety of sort of half-baked projects that people have been building on Hypercore just as hobbyists, and so I didn't want to go through all of them, but one of them that was intriguing to me was a shared kind of OpenStreetMap or kind of distributed Google Maps alternative. And one of the cool pieces of tech that they use to power that is they built a spatial index using Hypercore. A spatial index is one
Oh,
in which
okay.
you can search a multi-dimensional space and find points that are similar to the points that you queried within it. And that is the
Ah,
same concept that is used when looking up similar embeddings in embedding space. And so you could imagine taking that spatial index that's built on top of Hypercore and exposing that. And then we could do exactly what you said, which is you could do maybe some semantic search applications over this distributed vector space.
yeah, and for our listeners and viewers that haven't caught up on our AI episodes yet, the embedding space is basically a high dimensional vector space where AI take all their learnings and compress them into this abstract space where they hold meaning, which is like relationships between concepts. So you can do things like what is it?
King
Sorry,
minus
hold on.
man plus
Yeah,
woman
yeah,
equals
yeah, yeah.
queen.
Right.
That's
That's
what
the
you're
one I
gonna
was
say.
looking for.
Yeah.
Right. And so it's you have a spatial relationship that holds these meanings. And so that's what we're talking about when we have the queries in the embedding space. So yeah,
Yeah.
that's really interesting.
Yeah.
Hmm.
Yeah.
Hmm.
So I think I think what's cool about this and what kind of this is maybe controversial because I haven't actually used this like in great depth, but what's interesting about Hypercore versus a very similar but much more popular project like IPFS is that it's structured data, and it seems like this core data structure, the append only log, is able to power a variety of different higher order data structures. So things like databases, key value stores, spatial indices, maybe a knowledge graph, all kinds of things on top of it,
Repos, yeah.
repos, all kinds of things, right? And so
Blockchains, yeah, yeah.
it seems like it's a good mental model to build distributed apps because files are fairly limiting. They're pretty well, actually, I won't say that because Plan 9 as an operating system,
Unix, right? Yeah, yeah,
Unix,
yeah.
really built on top of files. But I would say that, there's something kind of seductive to me about the possibility of being able to imagine a type of data structure that I needed for my application. And I can imagine that I need a certain data structure and then being able to implement that on top of Hypercore and have it be flexible enough to adapt to the needs of my application. I think that gives a lot of power and empowers people to be more bold in maybe making their software local first and peer-to-peer first rather than going for centralized solutions.
Yeah, I mean, I think the rightfully so, a lot of these peer-to-peer projects identified that one of the main reasons that people don't build distributed systems like from the ground up is because it's hard, right?
Yeah.
It's like harder than just throwing things up on a centralized server or having one machine. Like by default, you just throw there's a whole bunch of machines, and I forgot who said it, but like you shouldn't be allowed to use more than one machine if you haven't even mastered using one.
Yeah.
And so, so the the fact that they're able to build some of these building blocks to make it easier to build some of these other applications on top definitely is a boon. And I think there's definitely room for this, but I think the which will excuse me, I think one of the issues that we'll talk about later is like what is the thing or application that this sort of architecture uniquely enables, because so far like a lot of the stuff that we've seen that are being built on top are just things that clone existing centralized services. And my sense is that like data ownership by itself is necessary but not sufficient.
Yeah, so actually that's a really good point. The one of the core contributors to the Hypercore project had a good write up about this as well, which is that the biggest impediment to the adoption of peer-to-peer technologies is that it's really tech heavy in order to build up all of these protocols and platform. But at the end of the day, what the users care about is what does it enable them to do, right? And so if after all of this work of building really cool distributed data structures, you say, well, you can do the same exact thing that you can already do with Dropbox, it's not super compelling. So I think that's a fair point. Did you have anything in mind in terms of something that we could do with these that you wouldn't otherwise be able to do with centralized services?
The immediate thing that came to mind was IoT devices. Like for me personally, and I think a lot of people on the Orange site would probably fall in line if there was a Roomba, like a vacuum and like a home surveillance company that lets you own and keep your own data. I mean, recently Roomba sold to Amazon, right? And so I saw a snarky comment in a weather app, like in the weather they would have provide social commentary that Roomba sold to Amazon, so it would have a better layout for police raids to come in and raid your home. So
Oh my god.
I mean, like the haha there is, you know, like there's a lot to unpack there, but we won't go into it because that's not our show. But I guess that goes to show you that there is a significant portion of people out there that are more and more privacy conscious and data conscious because I think the idea of big tech like and the things that they're doing with your data, you know, is filtering out. And so maybe with your like digital communique feels a little different than like information about your physical home. And so I think the awareness is slowly trickling out. And so that's why I say in the immediate term, probably something like that. I know I would probably jump on something like that.
Yeah, I think that's a good one. And yeah, recently there's been a lot of controversy as well about like Ring giving data to police without the user consent and things. Ring being the
Yeah, yeah.
doorbell surveillance cameras.
Right. Like they cooperate with local law enforcement without the well by giving out the video footage without permission of the owners. And so Ring both has they have devices that look both outside the home and inside the home. So I mean
Hmm.
that's yeah, yeah.
Yeah, yeah. So I think people are skeptical about Internet of Things, and I think that's a good one for Hypercore as well because Hypercore has the append-only log database, which you can tail. Like you can tail this log, similar to like listening to a Kafka stream or
Oh,
something like this.
yeah.
And
Right.
so
Uh-huh.
like IoT is exactly that, right? Like it's sort of point measurements that accrue over time for a lot of things. Like you can imagine a thermostat or doorbell events or whatever, sensor events, security
Yeah.
events. And so yeah, I think that as a data structure, Hypercore lends itself pretty well to this type of streaming applications, even more so than something like IPFS, which is much more file oriented. And so that's actually maybe a good distillation of what I was trying to say earlier, which is that having these type of dynamic data structures gives you flexibility to build things that simply distributed peer-to-peer file sharing would otherwise not.
Yeah, and I think one of the ways that Hypercore structures its data is that it enables streaming also, right? Like you don't have to wait on like a particular startup time because I guess
Yeah.
like I mean it's modeled like these distributed technologies. A lot of them are modeled after BitTorrent, but I remember like with BitTorrents, in order to have a video, you have to download the entire thing before you start streaming it, or maybe like this is out of date information by like 2 decades. Maybe you can start streaming now today. I don't know, but
Yeah.
presumably Hypercore claims that like one of its points of differentiation is that it really enables streaming of large files. And so that seems to be like a pretty good use case for IoT and not just like watching files over a distributed system.
Yeah, exactly. Yeah, so one of the selling points, the unique selling point in one of these write-ups was that it is exactly streaming, and by what we mean by streaming is that you can start at any point in the stream, so you can seek around the same way that you would if you were streaming a video or something like that. And so yeah,
Yeah,
yeah.
yeah.
So yeah, I think that's a really good use case. Yeah, I mean I've just generally been thinking about what would it look like if data were to be an asset, a shared resource. And so I think that a lot of data is also locked up in centralized services, things like knowledge graphs, right? So descriptions of the world's facts. A lot of the time,
Wait, of the world's what?
facts, yeah,
Oh, facts.
facts about the world, right?
Facts
And so,
about the world.
so there are projects, right, that are like Wikidata, which do input, facts like how tall is Obama, and where is the location of the Eiffel Tower. All of those are stored as facts in a database or in a online on something like Wikidata, but it's sort of not a dead resource. It's like a static resource, right? In order to actually build something interactive on top of that, you would have to make a copy of that.
A lot of work.
Yeah. You'd have to download with a Wikidata dump or something, and then maybe put it into a SQLite or some other way of indexing it, and then making that searchable, et cetera, et cetera. And it seems kind of cumbersome. I actually don't know. I've never done that myself. It doesn't seem like something that would be appealing to any programmers that I know to like actually make use of this type of shared resource, right?
Yeah, yeah. So go on. I actually have you triggered a thought, but go on, finish.
Yeah. So I think it'd be really interesting if this type of shared resource was exposed as a searchable data structure on Hypercore, and then people can start building all types of remixes on top of this shared resource, like the same way that people used to build kind of remixes off of Yahoo pipes, because you could just get like
our middle school experiences that never die. Yes.
Yeah, exactly. So imagine that you have the world's data at your fingertips that you can query on the fly, right? And you don't have to host yourself. You don't have to download the data dump yourself. You can imagine people would build a lot of interesting utilities to search that, to visualize things, to map out maybe some cool places to visit in each city, things like this, using the shared resource.
Like the thing that you described is the vision of like data.gov, where the government, whether federal or local, want to expose their data so that like everyday programmers and citizens can build apps out of it. And by and large, it's so difficult because one, the data is in a format where it's like you're lucky if it's CSV. Like otherwise, and like if there's something that's described, like so the format is heterogeneous, like you're almost never sure what it is, and it's sparse, like from city to city, county to county. The like just because one county has a set of data, you may not be necessarily be able to find that in any of the other counties. And so, not to say like just because they put it on Hypercore that would be the case, but at least you could see like what's missing, right? And so I think a lot of it is just because they're so resource constrained that effectively they put a website in front of a Microsoft share folder. Like that's what it feels like, right?
Yeah.
And so if they put it on something like Hypercore, then they get all the querying for free, and they get versioning for free, and as long as they pin the version, like everybody is like keeping it. And if for some reason there's like an attack on the government and they lose all their servers or something, like people that are using it, the community has backups, so they could just restore it pretty easily as well. And so that's somebody on Hypercore needs to get a government consulting job or something like that, maybe, because I'm pretty sure people in the government do not know about this. Because I have a friend that worked in the digital service for a couple of years, and he's never ever mentioned this, like Hypercore sort of stuff.
Yeah. And I think that there are good people in the government, a variety of governments throughout the world and the country, that are interested in things like building smart cities or exposing the data, the public data to the public using things like APIs and visualizations and things like this. But more often than not, they have to spend a lot of money in order to get this data to the citizens.
Bad consultants that are not worth their salt. I mean, seriously, like how could you blow millions of dollars on the insurance website that didn't work?
Yeah.
And then they're like, who's it? Matt Cutts from Google had to like bring in all the people from Silicon Valley to say, okay, we're going to do it right this time.
Yeah, exactly. And
they managed to get it up and fix some of the problems. And so, a lot of sorry if any of our viewers are government contractors that work on websites, but man, like you guys don't necessarily have a great reputation, so that's something to work on.
Yeah. So I think like and on the government side, I think there are people who do want to get this type of data out to the people, and if they knew that there was this type of tool, maybe they would have to still hire some consultants to like do the nitty gritty of like actually structuring the data and getting it into the Hypercore format. But after that, I think maybe the running costs of such a system would be lower.
They get a lot of stuff for free as a result of how Hypercore is set up.
Yeah, exactly. And not just government, but a lot of scientific projects as well. I think one thing that I've gotten interested in is just like gene sequencing and like genomics and
Oh
stuff like this.
yeah, and like the recent like protein database of like that deep mine has been like accumulating.
Yeah, exactly. And I don't know if those are proprietary. I imagine that they would want to expose this to the scientific community and the world at large because this can really accelerate scientific development. And the same thing, a lot of scientific data sets are lost because there's no good place to host them, or they sometimes they get hosted on like academic web pages and things like this.
Yeah, like personal sites. And
Yeah.
like I complained about this before with like they might put like at least with like deep learning papers, a lot of times they're putting their code up on GitHub, whereas before it's just unavailable.
Yeah.
But like with deep learning stuff, you also need the data, and usually it's hosted on some like university server through their personal site. And once they leave or they, I guess, I don't know, like go somewhere else, like the data is nowhere to be found. I'm always just like, just please put it on these distributed like IPFS or something.
Yeah.
Hypercore is another good candidate. And so yeah, I guess. I mean, I'm pretty sure the team at Hypercore is limited, but this is probably a good idea. Like finding common data sets that niche communities would really love to have around. So like protein or like even just mirroring that. Because I think one of the things that they did was to mirror the Ethereum blockchain. And so with HyperBee, you can actually query it in the same way that like, so Google was able to put the Ethereum blockchain data into BigQuery. And so people can query BigQuery to be able to tell the state of various Web3 projects, like, you know, how many ETH is locked up in this particular project, like what are the different transactions and how do they accumulate, where are all the whales and that sort of thing, like whatever questions you want answered. And so they demonstrated, I believe, in Hypercore that they could do something similar by putting the entire Ethereum blockchain data into HyperBee and then be able to query on that as well. And they could do that in a decentralized manner. So I think they could just go with that playbook, just do that more across like a lot of different data sets for specific niche communities that are starving for this sort of stuff. And I think they'll really get adoption in some like core niches, because I don't think by any means like IPFS has one or anything like that.
No, definitely not. I'm thinking about the characteristics of the data that would lend themselves well to this, and I think if especially data sets that are large and expensive to host by any one organization, maybe that doesn't have as much funding, and then data that is sort of a foundation on top of which there may be other groups who are iterating off of that type of data. So you can imagine like gene data, for example, a lot of scientific labs are all using that same data, right? And so they can all serialize on this one, let's say a HyperBee database, and then run their own queries and iterate on that. So things that are large but also shared and foundational across a broad swath of people would really lend themselves to that. And yeah, so I think that'd be cool.
Yeah, and then alternatively, I was thinking like what sort of data sets are also large and people would benefit from sharing it, but probably don't. And like product information comes to mind, like what are the names, what are the current prices, that sort of stuff.
Yeah.
What are the descriptions? And the other is real estate listings. So I can't imagine those two categories getting onto Hypercore, even though I think it would lower the cost of a lot of things in those industries if those were available. Definitely like a whole bunch more tools would be available, and a lot more upstarts would probably be able to do something with that data. But you know, that's probably the precise reason why incumbents wouldn't want that sort of stuff out and about anyway. So
yeah,
we'll see. But yeah, I think there's plenty of other candidates, like you mentioned, with the scientific and the cryptocurrency and stuff like that.
Yeah, those are some use cases which are not just let's clone some of the apps that exist already. And you know, one of the interesting things that the Hypercore team was imagining was that all of this could be powered by a small appliance or something that you keep in your home that hosts your Hypercores that then you publish for all these different application-specific use cases.
I think they're onto something with this thesis, because definitely if there's a subreddit for something, that means there's probably an interest out there. And the subreddit I'm thinking about is self-hosted, like r self-hosted. And these are all people that want to host as many web applications as they can with their own servers at home.
Yeah.
And normally people don't do this thing because people don't really want to run servers. Like even large companies don't want to run servers. I think we mentioned this before, right? Like it's just a lot of work to run your own server, and you really have to have a strong belief currently in order to go through the amount of pain it requires to like host your own stuff, like email server or whatever it is. But like I think what nerds and teenagers and rap artists do on the weekends is what we'll all be doing like in 8 to 10 years. And I think like if the ease in which you can host and manage this sort of stuff drops, then I think more and more people will choose it. So I don't think it's out of the question to have a home appliance that sits in your garage, maybe that kind of like right next to your water heater,
Yeah.
that serves up the web applications for your home and your life that you can also access outside the home. Recently, I discovered like with your Steam application, you can actually play your games on different computers, and the computer that has the game installed will stream it to your computer over your local network or like outside your home as well. I haven't tried it, but like I'm like, if this works, that's like the dream with like other web applications. Like you're able to control the nexus in which like your personal data is used by different applications and different people within your lives.
Yeah, exactly. Basically, what's interesting about Hypercore is that if you think about the traditional idea of self-hosting, it's quite fiddly in that you have your home server and then you bring up some services in the right configuration, like a MySQL database and something to serve the front end and things like this. And it's all very code oriented. Whereas I can imagine that a Hypercore personal cloud appliance would be very data oriented in that the state of the system is persisted in this very easy to traverse and serialize and persist data structure, the Hypercore. And then you can have very lightweight programs that simply read this data structure and then manipulate it. So rather than the complexity of running a variety of services, each of them persisting data in their own way, maybe storing it in memory and having some transient state that could get lost if you were to reboot your machine and things like that, you can almost just structure your personal cloud maybe similar to the way that you would a functional reactive style, in which you start with this data structure and then all of your applications are simply like pure functions that update that data structure, and those updates get propagated across all the different clients that you want to access your data on.
So I'm guessing the assumption there is that you have to trust the app provider to do the right thing and maybe not copy your data to some other centralized server or something like that, right? But like given, like I'm not sure how you would audit that, but maybe you can just watch the network to see whether they're sending stuff over. I actually have no idea. But like assuming that that's like a solved thing, that's relatively trivial. I think maybe it's not trivial. Maybe there's a lot of work to do there. But yeah, I mean that does remind me of what Joe Armstrong talked about in one of his talks. He's the inventor of Erlang, and he has a talk at Strange Loop called "The Mess That We're In," I believe. I think at the end of the talk, he talks about how we kind of got it backwards. Like we're sending data around, and maybe it would be better if the data was at rest, and instead we're sending applications around. And the way that we do that is that are immutable, so that you can ship them around. Like he didn't go into a lot of details as to like exactly how this would work, but that was the key idea. He wanted to flip so that we don't have all the problems with data privacy with the large tech companies that we do today. And so,
this sounds intriguing.
I mean,
I have a crazy idea. So you could have a server, which is kind of a blank slate server, which simply has your data stored in these Hypercore structures, and then you could dynamically download some application, then run it, and it updates your data, and then that's it, right? So you can it's kind of like you can dynamically bring the programs down to your server and have them provide some functionality and update your data, or view your data or render your data, and then it goes away. So you're not sending the data around; you're bringing the code around.
Yeah. Well, you can also just cache it, because if it's immutable, you just keep it around. There's no reason to update it or anything like that. Yeah. So then, were you picturing something like really small utilities like Unix, in which you then can bring them up and combine, or would they be like apps in the larger sense of mobile apps? Do you get what I'm saying? Like Unix utilities are kind of really, the granularity is more fine, and you have to like combine them to do stuff, but at least they're composable, as opposed to, I think with our self-hosted, like they usually think of apps in terms of web apps where you can't really combine them, and they have like a job you typically think of as broken up into services rather than like really fine. So like it would be like mail or bookmarks or something like that.
Yeah,
So
I see what
yeah,
you
I
mean.
wonder. Like, so like, what are you thinking the granularity would be?
Yeah, so one thing, I don't have a super clear answer to that, but one thing that I think is appealing about this is that right now when we think about applications, like let's say a mobile application or full-fledged like web application, that data is in that silo of that app, and maybe you can export it into some common format or something like that, but you'd have to do some extra data interchange in order to do this. And actually, the biggest
Crap
yeah,
work
crap.
is what you're looking
That's
at.
right. That's the
Right.
real way to describe it. But yeah, so I think there's actually a lot of class of applications where everybody is like nobody's ever satisfied because they don't have quite the tools that do exactly what they want. So if you look at people who are super into note taking or to do list
Oh yeah, those
people,
guys.
right? Like they're always trying to fine tune their workflow and like get things
But
to
never productive.
never productive, never productive. But I think a lot of the reason
Right.
why it's not productive is that they're fighting the tools, right? The tool is the one that is managing the state of their to do or the state of their notes and the relations between the notes and things like this. And they're always trying every week a new note taking app because maybe this one exposes the functionality that I need in order to do this thing that I'm looking to do, right?
Yeah.
And so I think that what's appealing about something like Hypercore is that you could say it's data oriented, right? You have a notes Hypercore structure. And maybe this would have to be standardized in some way for this to work, but you can imagine the same way that Unix utilities work on flat text files, and for the most part, you know what you're getting when you see a flat text file. You could
Yeah.
have some standardized way of representing notes and calendar events and to-dos in a Hypercore structure. And then the fun part is that you can have a marketplace of apps that then interface on top of the Hypercore structure and have different views, different workflows on top of that. And then if you're not satisfied, of course, you can build your own. And so it becomes much more of the data becomes a shared resource, which is not at the mercy of even the representation of an arbitrary application.
Yeah, and I guess I'm trying to picture that world, and that's why I was wondering about the granular. Yeah, and I'm trying to picture that world, and that's why I was asking about the granularity, because then the experience would be a little bit different. Because then, if it's more coarse, like apps as in mobile apps, you would like click into the like mail, and then maybe you would be able to send a little bit something over to your calendar, so that I don't know, you can get the address that somebody sent you in an email into some sort of a event so that you can look it up when the time comes. Versus like Unix utility, I guess it would look a little command line-ish, or maybe our favorite, like Yahoo pipes. Like you just deal with everything as Yahoo pipes, and all you have are pipes to
Yeah.
like do little things for you. And so you might have like a major app, like a mail app or something like that, but like for all these like process, like time-saving tasks that help streamline your process, they would be some equivalent of Yahoo pipes where you're just like funneling data across these different systems that are accessing the Hypercore data within Hyper-P or HyperBee or something like that.
I think that there are a variety of different UI and UX models, but actually, you know who is a group of people who are almost living in this future or living this future, and they have been for the past few decades?
No, who?
Emacs users.
Yeah.
So if
Yeah.
you talk to Emacs users, and Emacs is actually we should do an episode about this as well. But like, there's a particular project in the Emacs ecosystem called Org Mode, and Org Mode
Yeah.
at face value is just a note taking app, like a kind of structured note taking app.
Yeah, I've heard it described it as an outliner, which
Yeah.
probably undersells it too much.
Yeah. So an outliner similar to Roam Research and things that people might be more familiar with these days in the modern world. But the interesting thing about org mode is that it is sort of semi-structured data in that you can structure the data within org mode in such a way that it has some semantic meaning. So certain things can be structured to represent like calendar events or to-do events or contact, within email and phone number and things like this. So it's sort of semi-structured data that's all using this shared org mode data structure. And then the interesting thing is that how org mode users work is that they install different modules and plugins to Emacs that then read this org mode data and then present different views and different interfaces to manipulate that.
Yeah, that might be a better model for what you're talking about in terms of apps coming to the data. I haven't used org mode that much, so I can't. I can picture it in the abstract, but like I don't know concretely what it looks like or anything.
Yeah.
But yeah, that would be interesting.
Yeah, they tend to look like kind of terminal UI programs. So they're not like command line utilities necessarily, but because or Emacs is a text editor, like it doesn't expose like the full range of GUI elements, but they're fairly full fledged.
Yeah, it's the equivalent of Command K or Command P in a lot of web apps now, where you can like type in some command and it auto completes.
Yeah,
Like
yeah,
that's like a poor man versions of like what a lot of these old school Emacs and Vim do. So
yeah. So I think that could be interesting to have the self-hosted servers and to think about different ways in which the data can come first rather than having apps be the center of the world and the data is secondary to the code and the services. I think there are few impediments to the adoption of Hypercore that if those were to be resolved, it could get more mainstream. I think one of the write-ups that we read for this episode calls out that peer-to-peer networking is non-trivial. And we can't necessarily take it for granted.
that should be a T-shirt.
Yeah.
Yeah, so it's an understatement.
Yeah. So, and the hardest part is sort of the last mile. In the big picture, the idea that you can share data across peers across the internet as a whole is actually more or less a solved problem, or we have a good handle on. But the issue is that when we're talking about using these personal apps where you would want to access this data on your phone, from work, at your friend's house, at public Wi-Fi, all these kind of things, the network environment is not necessarily conducive to peer-to-peer because a lot of these routers that you're connecting to don't expose the full range of ports. You need to do NAT traversal and things like this. And so actually,
Yeah, it's not an easy problem. Although like IPFS, the organization released a libp2p so that it handles a lot of these like hole punching things so that you don't have to deal with them. So for those of you out there that are interested in building your own distributed apps, I mean that's I don't think it's tied to IPFS, so that's something that you can also leverage because like definitely like these orgs really believe in the decentralized vision. So you're able to like leverage a lot of the hard work that they did in the last 7-8+ years.
Yeah. So I think hole punching is something that's part of Hyperswarm or Hypercore as well. But they do call out that there seems to be some edge cases that prevent it from working on mobile, which is where I think most people are working natively these days. They want their data to go on the go, and so hopefully some of these can get resolved. So I think that's the biggest thing for how do we get there. And then I think the one that I like that you called out was just making a lot of these use cases more concrete and getting the story to the right people. Because right now, if you go to the Hypercore website, it's like, this is a data structure. And I've never seen anybody besides maybe us and our viewers get really excited about a data structure. You know? Yeah. So I think that there are some concrete user stories that maybe they need to write some white papers and use cases and things to go to different people and sell them on this idea that they should contribute their data to the network.
Yeah, it could be kind of hard because like one of the things that crypto has as an advantage is that they're tied into a financial system of some sort. So like the Ethereum Foundation is able to sell Ethereum and raise money that way as a way to both pay for the project itself for Ethereum, its own research, and have grants like to other teams that are willing and want to build on top of Ethereum. And so that's one of those advantages of crypto, that it has that economic engine to kind of keep it churning, whereas Hypercore is dependent on like a much slower cycle, I guess, if it were to be successful at all. And so they might need to find a different way around this like cold start problem.
Yeah, that's a good point. Yeah, and I think I don't think Hypercore is unaware of blockchain.
I get the sense they were well aware of the advantages of all that stuff, and I'm pretty sure they thought about it because they even have in their fact is like, why is Hypercore not more mainstream? Because I think the feedback that they get from developers like, this stuff is awesome once they looked into it, right? But I think the awareness is not quite there, and so I guess maybe having the Technium feature the technology will help a little. Maybe our subscriber list is small, but those of you out there are pretty powerful. So I guess, like have at it.
Yeah.
If you got like a project or something that is a good fit for Hypercore, maybe consider looking into it.
Yeah, I agree. It seems like from the API and things, it's no harder to incorporate as reading a SQLite database or something like that. So yeah, for my next little hobbyist project that I do, I'll just try to store the data in Hypercore and see if I get distributed data structures for free, right?
Yeah, I think onboarding is one of those like harder like things that have a lot of bang for the buck, but I guess they don't have the bandwidth to work on it. And it's also kind of tough when you've worked on something for years. You're not exactly sure like what newcomers don't
Mm-hmm.
know. And so we did have a post where somebody described their experience on uh, Hypercore when it used to be called DAT. And we'll link to it in the show notes. But one of the things that they played with was being able to clone a app called Muxtape, which was a digital mixtape that you could create online. And the centralized version got shut down pretty quickly by the music, like MIPP or whatever that acronym
Yeah.
is, the Music Association. And so the thing here is, oh, could you share mixtapes? Which seems like perfectly within the realm of fair use, at least on cassettes did. But like the music industry always like overreacts when it comes to like new
Yeah.
mediums, right? And so could you have something like that with like a decentralized thing, and then it could just not be shut down? But the thing is, when I tried to, so in the blog post, one of the things that was claimed was that this was an application that could never be taken down, but I guess there wasn't enough interest in it that I couldn't actually access it through the Beaker browser or anything like
Yeah.
that. And so, I mean, I guess I guess in some way, like you need enough attention on something for these things to stay on the network, because like if nobody pins it or if nobody seeds it, then it just goes away from these decentralized networks. So yeah, they're definitely like the issues that you brought up about availability, durability. Like there is something to having like a server that like holds onto this sort of stuff for you, but then you run the risk of centralization all over again if there's like a node that is more special than some of the others.
Yeah.
So I don't know, maybe there's some way around this.
Actually, you know what? This reminded me of this problem of nobody seeding something, some obscure piece of content, is something I'm well familiar with, because this was a lot of the life of somebody who used BitTorrent a lot. Did you use BitTorrent?
Oh yeah.
So
Yeah.
so if you're looking for like more obscure songs and albums and movies and things, you have to hope that somebody has a copy around and is sharing that. Otherwise, the torrent is a dead torrent. And so, well, actually, one incentive structure that people have figured out is to create these services called trackers. And a tracker is basically a directory of users that you can join. And these trackers would keep track of what your seeding ratio is, like whether you're a net contributor of data or whether you're a net consumer of data. And
like back in the Wares days with the Z.
Yeah, exactly. I never downloaded anything illegal. I was only downloading Linux ISOs, but
Oh yes.
but yeah, so and you would get booted from the tracker if unless you maintained a certain ratio of sharing versus downloading the data. And so I could imagine that for things like this, where maybe there's not a lot of attention and not a lot of immediate need for something, but you still want that data to be available, you could have some kind of tracker model in which somehow you incentivize some group of people who are data hoarders, or they're just interested in accruing some points on this tracker, incentivize them to keep a copy around and expose it on the Hypercore network for somebody who might want it, even though right now there's not a lot of demand for it.
I feel a little unsatisfied with the future effects, but I'm not sure exactly why. Maybe I think the core question I want answered is like, what does this uniquely enable? And I don't know that I have an answer to that. And in our discussions, we haven't really quite come up with it. A lot of it is like replacing current things, but I don't know. Maybe the answer is really just if you have apps. No, I mean that's not entirely true. I think the thing that it would be like, you have to imagine a future in which your data is core to you, because I think when it comes to web apps, it always feels like you're going somewhere else to do something, right?
Yeah.
And I think the different feeling with these distributed apps, if this future comes to be, is that things like you are always situated with your data and your picking up things to work on your garden rather than you going somewhere to do something. Does that make sense?
It does make sense. I think that's what people mean when they say things like data autonomy and things like that. It sounds very abstract and like some more focused on like rights and things like this.
Things that are kind of like things that people would march in the streets for, and you're like, I don't get it.
Yeah, it sounds kind of political, and I'm like, I don't get it, right? I don't have time for this. But yeah, I think it is what you're saying, which is that your data is central to you. It's something that you own, that you have the right to, you have the ability to take with you, right? And the tools are secondary to
you, right? Yeah, like it feels like it's you, kind of in the same way that I think a lot of us feel like the mobile phone is an extension of us. And like we carry it around. Like when people can say, oh, can I borrow your computer? And you're like, okay, like as long as you're not doing anything strange, like it's perfectly fine, right? But like only in like more extreme circumstances would you ask to borrow somebody's phone, because like you lost your own and it's an emergency and you need to like call somebody for a ride or something like that, right? Otherwise, nobody's going to be like, let me borrow your phone so I can look up like something completely trivial, right? And so like because like mobile phones feel like an extension of ourselves, and it's like uniquely personal. And I think if the decentralized future comes to pass, like it's not like these like things that people espouse as like rights and values that I think will be the change, but kind of the visceral feeling that my data is me. And instead of going somewhere else to do the things that I have and other people are holding it for me, I own the things, like the things that I've written, my emails, my documents, they are me. And then I'm just looking for tools to help massage that. But at the end of the day, like that's all my stuff. So like you couldn't like just borrow it for no real good reason. So I think that that's kind of the change in mindset that probably has to happen before some of this stuff comes to pass. And maybe there's going to be like a particular data set. And right now I'm still grasping, because like some of the things like note taking and like maybe social group things, that it's kind of still on par with things that already exist, and people are kind of still like okay with that. And so maybe the only thing I can think of is like the IoT stuff. But I think I'm still grasping at like the failure of my imagination to see like exactly like where that path forward is, to kind of really ramp up my enthusiasm and optimism for like a way forward into this future.
I'll push back a little bit on this, which is that even if all we get out of this is that we get note-taking and document sharing and all of those collaborative cloud services, it's actually a net win over the current status quo, because we as consumers of apps have also bought into some Stockholm syndrome, where we think that the world is fine and Google Suite, Google Workspace is great and iCloud is great and whatever, but they're constantly changing up their subscription models, their pricing model, their quota, their retention policies, whether the apps they have are getting shut down or renamed or merged into some other sibling app, and you lose some functionality that you're relying on. These are not like some obscure, contrived scenarios. These are things that happen all the time, every month, right? These things get to the top of HN and people complain like, oh, I was relying on this feature and it's gone now, and they changed it arbitrarily. So we're sort of bought into the idea that this is how life is. And I imagine that if all we get are just clones of all the things we already rely on, but we have them on Hypercore, and we have the confidence that the data is ours and the tools are at our service, I imagine that using these things would be a lot less anxiety-inducing than it is today.
Yeah, but then like that idea has to be upfront at the moment of like during a consumer's purchasing decisions. Like at that point, that's the point where we have to vote with our feet in our wallets in order to make that happen. And I guess I'm not as confident that we're there yet in our collective attitudes about this. And so even beyond consumers, like for me as a developer, like I would also need to choose these technologies because I believe that I can better service my customers or my users through the use of these technologies. And like it's not a no-brainer yet, I guess is what I'm saying. And so like it once it does, I think that flip's going to switch. But I think like right now, because I'm trying to find that particular niche, so I agree that like even if all we get are collaboration apps, like that would be phenomenal. But like, because like when it comes to new things, they usually have to be a lot better along some other dimension and just suck at everything else. Like some dimension that people care about that's newish, that the old thing just kind of meh, in order to kind of find that foothold. And so like when I think about like, oh, would I as a developer choose Hypercore to build my next X? Like like I said, it's not a no-brainer yet. Like there's only very specific instances where it would be a no-brainer or default choice. And so that's why I'm saying like we need to kind of find that foothold before it becomes more of the default. And so like, what is that foothold? And so for me personally, trying to find that answer would feel more satisfactory, I guess, because like I think with some of the other episodes that we have, like I think it's a little easier to draw that line. So that, well, like whether actually that would happen or not, like at least I can see the gap on the football field. Like you see that gap that you can run through. But here, like it's still a little opaque to me.
Yeah, no, I mean I think that's fair, and the technologies that we cover are at different points in their adoption curve, and this one I think is a little earlier, like even for us to really imagine what it is. I think it's interesting that Bitfinex is using it for. I think what's an interesting use case, and I asked a good question of why did they choose it. Maybe they did a write-up of their process of using it. That could be something that would accelerate the adoption of Hypercore in other scenarios if the trade-offs and the benefits for, I think, what is a well-known brand, well-known company, if they are able to publish those and share that knowledge, that could accelerate things, because we mentioned this in the podcast a lot, is developers are also very trend driven, right? And so if there's some more social proof,
we don't we don't think of us as, but by far, like we are very trend driven. Honestly, actually, like I know like we're wrapping up here, but maybe one of the things is if these decentralized technologies enable a business model that subverts the existing business models, then that would definitely be something that perk up like any builder, right? Because then if, say, Google cannot actually do this sort of stuff, either because culturally or by their DNA cannot bet on decentralized technologies, right? And so maybe like one of the things is like you can provide services and networks where you can either it's free because it's commons, or you pay into it and you're not inundated by ads, then maybe, or like some combination of things, because like Google can't fast follow on this service because the whole premise of their business is that they vacuum up your behavior online, especially in their search queries, so that they can serve ads to you. Like if you break that fundamental assumption, then there's no way they can fast follow. And so maybe if you enable some other business model with existing human needs that have always been around, then that might be like an avenue attack. But I couldn't tell you exactly what that is.
Yeah. And if you have ideas about how you would use this, please leave it in the comments. We'd love to hear. Or if you've used DAT protocol or Hypercore or Beaker browser before, share your experience reports. I think that'd be really interesting as well.
Yeah, definitely. We'd love to hear from you, and we get excited anytime like people tell us that they like what we're doing, they like more of this, or they don't that, or like if you have other technologies that you would like us to cover, and we'll put it in our list of things to consider for next season.
Yeah. And if you are listening to this on YouTube, be sure to check out our audio versions on Apple Podcasts or Spotify or wherever you listen to podcasts. If you're listening to this on audio and you want to see our beautiful faces, come check us out on YouTube and find the video version.
We should shave more often then if we're inviting people to come look at us.
Yes. But yeah, write us a review on your favorite podcast platforms to bring other Techniumistas on board. And if you have other friends and coworkers who want to explore the edge of technology, share that with them as well. So with that, this is Shri.
And this is Will. See you next time. See you guys next week. Bye-bye.